The industrial heart of America is a landscape of ghosts. We begin in a graveyard of giants in Ohio. Here, among the rusted skeletons of the 20th century, lies a legend, the Peterbilt 379. This isn't just a truck, it is a cultural icon, a symbol of the open road, now buried under decades of dust and defeat. Look closely at the hood. You can still see the faded red flames against the rusted blue steel, the unmistakable livery of a leader. This soil in Ohio remembers the clatter of the Moraine assembly plant. Since 1926, this region saw the evolution of work, from Frigidaire refrigerators to the 6 million GM vehicles built between 1981 and 2008. When the lights went out in Moraine, it felt like the end of an era where what was good for GM was good for America. But in 2026, we don't believe in endings. We believe in the Prime Protocol. We are moving this titan from the Rust Belt to the Silicon Desert of Texas. A digital resurrection is about to begin. The sunrise hits the Texas horizon as we arrive at the gates of Samsung Taylor Plant 1. This is the new center of gravity for the global economy. Spanning 4.85 million square meters, this facility is a monolith of human ambition. It is larger than Samsung's legendary complexes in Pyeongtaek and Hwaseong combined. Built by an army of 7,000 workers, this 6-story cathedral was designed for one purpose: to anchor the 2-nanometer era on American soil. As the Peterbilt is pulled into the staging area, it is scanned by blue lasers, creating a high-fidelity digital twin. The truck enters the high-velocity airlocks. This is the clean room of history. High-pressure jets blast away 40 years of grime in a violent ASMR symphony. Decades of rust evaporate under laser stripping beams, revealing the pristine steel beneath. The flames are ready to burn again, but this time they will be fueled by silicon. The economics of this project are as revolutionary as the technology. On July 4, 2026, the signing of the One Big Beautiful Bill, OBBB, changed the math of American manufacturing forever. This $3 trillion stimulus provided the green light for high-tech reshoring. Under the OBBB, the Peterbilt is no longer just a restoration project, it is a strategic tax asset. The law now allows for 100% immediate expensing on industrial robots and AI infrastructure. What used to be a 5-year depreciation cycle is now a year 1 write-off. By restoring R&D expensing and doubling Section 179 limits to $2.5 million, the government has demolished the barriers to entry. Small shops and giant labs alike can now justify the cost of the future. The ROI on this truck has been compressed from a decade into a single fiscal cycle. This is how America automates, with unreal simplicity and massive financial momentum. Now we install the mind. We are moving past the era of connected operations into the realm of physical AI. At the center of this transformation is the Samsung AI6 core. This chip is forged using a 2-nanometer gate-all-around GAA transistor architecture. Unlike older FinFET designs, GAA transistor channels are wrapped on all 4 sides by the gate. This provides absolute control over electrical leakage and power efficiency. This specific AI6 silicon was part of a $16.5 billion contract originally destined for the most advanced autonomous systems in the world. As the robotic arms lower the iridescent chip into its gold-plated socket, we are closing the maturity gap. While traditional compute is now a mature commodity, Agentic AI is the new frontier. This truck will not just process data, it will perceive its environment, model the physical world contextually, and act with situational intelligence. The labor market is shifting, and automation is the only path forward. The average welder in the US is now 40 years old. The talent gap is a reality. To solve this, we use the Standard Bots RO1. Watch the mechanical ballet of these arms. They operate with a repeatability of ±0.025 millimeters. They are installing the high-voltage nervous system of the Peterbilt with a surgical precision that defies human capability. These are smarter robots for a brighter future. By integrating physical AI directly into the robotic controllers, the RO1 doesn't just follow a pre-programmed path. It senses the steel, adapts to the imperfections of a 1967 frame, and completes the wiring with unreal simplicity. The boundary between software and hardware is dissolving here in the integration bay. The industry is undergoing a massive, silent pivot. Across North America, 10 major plants are being repurposed. They are moving away from simple EV batteries toward energy storage systems, ESS. Our Peterbilt is a pioneer in this new mesh. As the RO1 arms lock the Samsung SDI battery modules into the chassis, the truck becomes more than a vehicle. It is now a mobile energy node. In a world where AI data centers have an insatiable hunger for stable power, these ESS units are critical. They compensate for the instability of renewable energy, feeding the grid when it's hungry and storing power when it's abundant. The Peterbilt is now a subject of autonomous workloads, capable of managing its own energy distribution while navigating the Texas highway system. It is a participant in the economy, not just a tool for it. The moment of truth. A technician taps the glass interface. Initiate Agentic AI. An orange pulse ripples through the cabin, the same hue as the EUV light that etched its processor. Inside the empty cab, the steering wheel begins a ghostly, autonomous calibration spin. There is no driver, yet the truck is waking up. This is the leap from connected to fully autonomous. This is physical AI in action. Unlike standard software, this system reasons about its own identity, its mass, and its relationship to the environment. The glass headlights flicker, then surge with a warm, volumetric beam that cuts through the integration bay. The machine finally sees the road ahead. It is no longer an object, it is an agent. The Peterbilt glides silently across the polished factory floor. It is a black and chrome Titan, a tiny dot against the monolithic arches of the Taylor facility. As it moves, it is greeted by a community of autonomous mobile robots, AMRs. They salute the truck with light pulses, recognizing the 2-nanometer logic that governs their shared ecosystem. We are seeing the realization of a path toward fully autonomous industrial systems. The maturity gap is being bridged before our eyes. Technologies like TOF sensors and mesh networks, once overlooked, are now the foundational infrastructure of this new world. In this mesh, the Peterbilt is the convoy leader, a mobile AI workload perfectly optimized for a 6G satellite-connected future.
Protocol complete.
The massive bay doors slide open. The mirror-black paint reflects the first vibrant stars of the Texas dawn. The air is crisp. The Peterbilt accelerates onto the open highway, its electric drivetrain rising in a clean, powerful hum. The dashboard confirms the status. 6G connected. Physical AI optimized. Through the satellite link, the truck is in constant synchronization with the industrial mesh. A gloved hand rests on the roof, a symbol of the enduring bond between man and machine. We aren't just passengers. We are coexisting with a system we have taught to value our heritage. The math of the one big beautiful bill has tilted the momentum of history back toward American innovation. This isn't just a drive, it is a victory lap for the 2-nanometer era. The Peterbilt heads directly into a vibrant orange sunset. As it moves, the black surface turns to liquid gold, reflecting the light of a new industrial dawn. It begins to disappear into the heavy heat haze of the desert road. The era of manual, repetitive labor, the era of hands without brains, is officially over. In its place is a world where history and 2-nanometer innovation drive together into the infinite. The truck vanishes, leaving only the silence of the empty road. But if you listen closely, you can still hear the rhythmic digital pulse of the AI6 core echoing in the stillness. Old things never die. They simply become the heart of everything that comes next.